Hey guys, welcome to the Real Hacker Hours podcast. This is basically a spot where I just do the projects and the work that I normally do in my free time. However, I just hit the record button before I do some of it, and I just talk and explain what I'm doing as I'm doing it. Here, I am working on more SQLite vulnerability research, SQLite 3 particularly. So, what I did was let me see if I can't pull up. Okay, so I fuzzed SQLite 3 using a large series of queries. These are some of the error. Well, these are all of the error types that I found after multiple iterations of running like 100,000 queries. By these are all the errors, I mean like these are all the error types. Each of these that you see were outputted like thousands of times each. I know last time when I looked into as a parser stack overflow, what that particularly was from what I saw when SQLite part of the functionality, what SQLite 3 will do is it will give it a command, it will parse it, and after it parses it, it will convert it over into opcodes for its custom VM implementation and then run that functionality. And that will be where it actually executes the does the actual functionality for whatever the SQL query is. Now, with this parser stack overflow, what that was for particularly was, excuse me, I'm hicking, well, burping. Okay, sorry about that. Yeah, what that parser stack overflow was, in SQL, there are different clauses. It could be like insert into a table these values from a select statement. And whenever it's appeared that like whenever you had a SQL query with a ton of different clauses to that, like nested select statements and stuff like that, this stack would grow and it had like a set hard limit size. Unfor- and then it appeared to be like an overflow that we could that could be used in attack. Reason for that being is it's not like it's a select buffer that's allocated and we can write past that. All additional memory that is written or allocated for it is done through like a malloc or a realloc call, and every time the stack grows, the malloc or realloc is called. So right now, what I was looking at is just like one values for 4 columns. This could just be an issue with the SQL fuzzer I wrote using, or could be something else. What I did was I found the where it's happening, which is SQLite 3 error message, which is happening in the SQLite 3 insert function. What this function is responsible for is effectively when SQLite 3 is parsing a particular command, it has a bunch of different subfunctions that will handle particular types of SQL queries. This right here is for like retreat, which is called when you have like a SQL query like this, which is like insert into table followed by other things. And we can see we've scrolled. Actually, probably just Control F it. Yeah, this is called in this function. Actually, wait. Cannot parse. This is parse for the entire function call. Okay, yeah, here it is. This is happening within the same function. So what I did was in GDB, not GDB, Ghidra, I looked for the strings xref, which led me to here. At this particular address in the binary, just set a breakpoint for it and hit it. And what we're seeing, and this is the breakpoint currently here in GDB. And what we see here is if you look in the stack, well, the call stack for this, we can see like right here is the query that is being used. And you see insert into this table, call this 1 column, 2 column, 3 column, 4 column, 5 columns, 6 columns, 7 column, 8 columns. And the value to use is a nested select statement where the output is only 1 column. So that's the issue with that. I tried like hitting this breakpoint multiple times and it always appeared to be this issue, so it's just an issue with my fuzzer. Cool. Add that to the list of things to fix, but looking over this functionality, no such table. Okay, near for it. Okay, yeah, looking over the rest of these errors, there's nothing in particular I want to look at this moment. Instead of what I want to do, really, is take a deeper look at the parsing functionality to see if there's something interesting. So, let's take a... This is a SQLite 3 insert. Let's just quickly browse through and see what we see. Why reduce number? Select statement to use as a data source. Column name. Okay, so it's column names corresponding to ID list or no. Okay, cool. SQLite 3 selected the select object. Okay, okay, let's what is VV? Okay, so this where it starts actually allocating the VDBE code. No, let's copy this over into another tab so we can see exactly where that V is referenced, which stores the VDBE code, because I'm really interested in exactly how that VDBE code is generated and if we can at all, what real influence we have over that. Okay, so let's do V. Okay, so one thing, the V, we have the V, it gets allocated here, SQLite 3, get VDB. One thing that's just a slight side note that I just thought of is I'm just gonna quickly check what happens in this function just to see. I'm assuming it's just a generic malloc, just malloc size of whatever struct it's outputting, but I want to be sure. It's not void. VDB. It's pointer. Optimal C. So it calls the SQLite 3 VDBE create. Let's see what that function is. SQLite 3 DB. Okay, so it is calling malloc size of this. And it also adds on an opcode for op and net. By the way, one thing I'm just going to say right now, how it will append opcodes, which those opcodes are executed by the virtual machine implementation in here, which that's where the actual work for doing a SQL query is. But by that I mean, let's say that you have a SQL query which is going to select some values from the database. The opcodes are what will actually go and look up, oh hey, what are the actual values? Op and net, off the top of my head, I forget exactly what that does. I just know that it is the first opcode really executed in any SQL query. One thing that draws my attention right now is we see that there's a SQLite 3 it appears that its own custom malloc. So let's see if we can't just quickly see where that is and what that's actually doing under the hood. Raw finish. SQLite 3 DB size. Okay, I'm looking for like what the return values are. The return values either appear to be p buff or a call to db malloc raw finish. What is p buff equal if? Where's here? I'm gonna copy this over to another tab so I can just quickly control F for what p buff is. P buff if. Oh, okay, so it's an if then statement. Okay, I just was misreading it. Um, so it sets p buff equals to something from the buffer, sees if it's not equal to 0, then do that. I'm curious, what is this db? Man, this is a fun tangent to go on. SQLite3 malloc. It's probably. Okay, checks if it's within that range. Okay, yeah, I'm pretty sure. Just if we keep on looking at the function call, we're just gonna see a malloc. We might not see that, but for now, I think this is far enough down that little tangent. So okay, where are we? What is this a SQL? Yeah, this is SQLite3 insert. So we're back to here. We see that it calls the SQLite3 get VDBE function, which effectively just allocates a new VDB. Yeah, a new structure to store the VDBE code in. SQLite3 begin write operation. Curious what that is. Auto ink. Okay, so this looks okay. So it's a few things that are interesting. SQLite3 begin write operation. I'm gonna want to look at that. Auto ink begin. So what this particularly is for is some SQL tables. What they'll have is they'll have like an auto increment value. Sorry about that. And what that auto increment value is like you don't have to like specify what the value is whenever you insert a new record into the table. It'll just take the last value that was generated and just add one to it. So like the first record will have a value of like 0 associated with it, then 1, then 2, then 3, then 4, then 5, then 6, then 7. I know like I've used it as like sort of a primary key before. So I want to look at those two things, xref op 1. Okay, I'm kind of curious what that is to xref optimization, or x for optimization, I should say. Okay, block registers to hold the row IDs and the values for all columns and the new row. And we see, by the way, yeah, when it adds VDB opcodes to like the v variable, I'll do so through the use of like a SQLite3 VDB add op3. Now, for the various types of opcodes out there, it will have different VDB add functions to add those corresponding opcodes to. It isn't like a one-to-one sort of scenario, but there are multiple. VDB. Now, is this happening? It probably is happening in some sort of while loop. Are there like while for, I'd guess. Reason for that while. Is this like a do while? No. Okay, cool. So, hey, okay, I'm gonna take a quick break, BRB. Okay, so I'm back. So let's take a look at like this first. This SQLite3 begin write operation. We see that the arguments are pparse, select, and ptrigger ordered together, and IDB. Let's take a look at what this is probably enum if I had to guess. P tab, p select state. Actually, never mind. I got that wrong. Okay, what is IDB, which was used here? IDB equals schema to. So this is the schema. Okay, let's take a look at this. Actually, let me start my music back. Okay. So let's take a look at what this function is. SQLite3 begin write operation. Guessing it's a void, yes. Generate VDB code that prepares for doing an operation that might change the database. If you're already within a transaction, so okay, we can see effectively calls these three functions SQLite3 parse top level from the parse. Okay. Let's take a look at this first. SQLite3 parse top level. Okay, cool. So it does that. Nice. Look, take a look through this. Okay. Cool. So yeah, effectively it just looks like it's not directly generating any like VDB code, which I was pretty sure of that from the fact that it's not referencing V at all, and V is not getting which stores VDB code. Looks like it's just effectively checking some masks, or not masks, some like particular metadata about the database to see if it's already within a write operation or not. Okay, looking through 3 VDB count changes. Might be interesting. Okay. Let's take a look at this X for optimization. I'm curious of what it is. Actually, it's probably just declaration. Attempt the transfer optimization. Okay, cool. So we can see that it does a lot from that. What is the condition for an P call? Okay, yeah, it obviously does a lot. I'm not gonna be able to tell a lot from just a single look at it. So let's move on. Auto increment begin. I'm actually pretty curious on how it gets this value. Find previous static int auto. So okay, takes parsing contents, index of the database, and output tables. Cool, cool. So parses it. while. Verify that the sequence. Okay. Okay, cool. I'm trying to secretly think. Right now, I'm trying to see. Actually, hang on. Let's. Did the comment say anything? Okay. Okay. Yeah, looking at this, I'm not going to be able to tell exactly with great details as to how exactly it's doing it. I kind of expected maybe like it would parse out the schema and just be like, okay, this column has it has the increment value, but it's not doing that. Let's continue just like quickly looking through this. Single string. Okay, right now, probably not gonna be talking a lot this next minute or so. I'm just right now trying to like look and understanding better details exactly like what this functionality is doing. Figure out p select. Okay, according to this column, this is where it effectively determines how many columns of data are supplied. Is this op ephemeral make record? Wait, is this a recursive call that it makes to itself? Oh, select, okay. Data is coming from a select. Oh, okay, so this particular. Okay, so this right here, it's interesting because this code right here handles parsing what deals with when your values that you're inserting into it are coming from a select statement, which is why it's calling SQLite 3 select, which this right here insert select. Okay, cool. Make record. Okay, cool, and then it adds corresponding opcodes to that. Rows to be inserted. Okay. Register just order the table record. Loop to the top. Oh, okay, so it looks like the VDBE code that it generates for this select statement, it might be in a loop. Op rewind. This, I know this opcode is adding effectively, if I recall correctly, it moves the DB cursor to the table back to the first entry and sets it that when it moves to subsequent records, it'll go forward by 1. Column. Okay, cool. So, one idea that I think might be good to do in addition to continuing fuzzing is effectively look at all of the various different types of opcodes out there and see exactly where they get added and how they get added. Okay, which gonna find that function. And it's called VDBE operation, I believe. SQLite 3 VDBE exact. Okay, this is the function that actually executes the VDBE opcodes. And the reason why I just searched for a massive switch is because I just remember there's a comment here that says what follows is a massive switch statement. Because what actually executes the various opcodes is a switch statement. So I'm going to pause this for a second and just copy this over to a separate tab. Okay, I'm back. Yeah, this is the function right here that handles actually executing various opcodes. Now, one thing I'm going to do before let's just quickly look at the listing of all of the different opcodes out there just to make sure that there isn't one that is blatantly of interest that we need to look at. So I'm going to do a quick grep. Define op. This is an opcode that I know exists. Mistype the command. Wait. Miss op. Hang on. Pretty. I know it's defined on one of these files. I'm making some sort of smooth brain mistake here. Let's just try gripping for op column. Grep. Define opcodes.h. Okay, let's open up that. Opcodes.h, cool. Okay, so this is a list of all the opcodes. Let's just take a save point transaction pref next. Vacuum v filter v update goes up in it yield must be jump. Last if so sorter sort rewind non equal pure function might be interesting. S copy and S copy might be of interest. So function S copy and copy change count row real cast permutation insert of course set create b tree SQL exec that might be interesting to look at. If we open, okay, so let me just write these down. Things to look at: function op column op SQL exec, not column, copy. And why, yeah, why not SQL copy too? Okay, cool. Let's go back to SQL. Actually, where's VDB? Yep. Let's see what op function actually does. Invoke a user function P4 as a pointer to a SQL-A3 context that contains a pointer to the function to be ran with arguments taken from register. Okay, so it's executing a user function that is of interest. This is the code where it actually handles. This function inside of a trigger. The register array in a mem might change. Okay. So, oh, this is for both the pure func and the function opcodes. They're both are the same. If this function is inside of a trigger, p out. I'm trying to see, like, is it like a function is established somewhere that is called from this context? SQL value. If the function returned an error, throw an exception. So that had to be executed. If it is executed here, it had to be executed. Before here, we see assert mem set type flag register mem about to change. PCTX equals. Let's see where this is actually called from to get a better idea of what this is actually doing. Op function. Add an op function, pure op code. Where is this called from? Oh, wrong file. Add function call. Where is this called from? Add function call. From this function right here, which is export code. Okay, let's take a look at this again. So the P4 register that contains a pointer has a context that contains a pointer to the function to be ran with arguments taken from registers P2 successors, the number of arguments. So PCTX P4 P3. Is it this? maybe? What does this function do? SQLite 3 VDB delete. Okay, here we go. If parameter IDB is less than 0, then invoke the destructor for all considering. So it appears to be just looking at it. It just checks. It's effectively running checks. So where's the function actually ran? Error. I'm blind. It's ran here. Okay, so that's, yeah, I was just blind. There's an indirect call literally made for it right there. Let's take a look to see what it looks like in the binary, because I'm curious if SQLite A3 VD BE. Right now, I'm gonna try to find where that is in the binary via just jumping to this function if it is called. I compiled this binary, since I had source code, I compiled this binary with debugging symbols, which means I can just jump to a function like that. I was a bit worried that, like I saw with a lot of different functions in here, it could have been inlined, but it wasn't, so that was good. So it's called in these spots, so you can just quickly browse through them. Nope. Call PGB. Okay, that's where it doesn't appear to be called there. That's really weird. No. No. Okay, that's really weird. Okay, so I've been going on this podcast for about 38 minutes now. I'm gonna just hit the stop button on this so I don't like have this thing go on for hours. Thanks for watching and see you guys later.